Hello, this is Chitran Saxena from Just Tutors. Today we are going to learn about pressure. The objectives of this video is, sorry, the objective of this video are pressure, pressure exerted by liquids and gases, atmospheric pressure. And before that, we are going to try some warm-up questions. So you can pause the video and try these questions. After that, on the next slide, you can check your answers as you always do. Here are your answers. And if your answers are correct, then well done, you have pretty good knowledge about the topic. So let's start. Pressure. You must have tried. If you have tried to hammer a bowling pin into the wall, nothing would probably happen except for people deciding to no longer lend you their bowling pins. So, however, if you hammer with the same force on a nail, the nail would be a lot more likely to penetrate the wall. This shows that sometimes just knowing the magnitude of the force isn't enough. You also have to know how that force is distributed on the surface of impact. Um, for the nail, all the force between the wall and the nail was concentrated into the very small area a small area on the sharp tip of the nail, as you can see here. However, the bowling pin, we were talking about bowling pin, yeah. However, for the bowling pin, the area touching the wall was much larger, you can see here, and therefore the force was much less concentrated. So, we can say pressure is a force per unit of area. The SI unit of pressure is Pascal and written as PA. So the equation or the formula we can say for the pressure is force over area. This is unit area. In this equation, force is the numerator and area is the denominator. This meant that pressure is directly proportional to the applied force but inversely proportional to the area on which it is acting, as it is mentioned here as well. Pressure is directly proportional to the force and indirectly proportional to the area. We have to remember this. It will going to help us a lot. So, relating this or with the help of that we have just did, we can say if we double the area, the pressure will get half, and if we double the force, the pressure will also get doubled. In this picture you can see that. Or if we keep the force constant and increase the area, the same force gets distributed over the larger area and hence the pressure decreases. So, in order to create a large amount of pressure, you can either exert a large force or exert a force over a small area, or you can do the both. In other words, you might be safe lying on a bed of nails if the total surface area of all the nail tips together is large enough. Another example we may think of a sharp knife and a blunt knife. It's really easy to observe and at your homes as well. The area of sharp knife is less than the area of blunt knife, so it is easier to cut with sharp knife comparatively to the blunt knife. You may have tried, and if not, you may try at home under the guidance or um, under the guidance of your parents or any elder. Now, pressure exerted by liquids. How does liquids exert pressure? Liquids and gases exercise pressure in the same way solid does. The pressure exerted by liquids at the bottom and the amount of pressure depends on the height of the liquid column. So always remember, the liquid placed at the height will give you the maximum pressure. For that you must have seen in your local colonies or societies a water tank for that society. It is made really higher so that the pressure may be maximum. The higher the tank will be, more pressurefully the water will release and tends to all the houses in the society. The pressure of liquid increases with increase in depth or height. We were discussing it. A liquid exercises the same pressure in all direction at a given depth. Say, let's say this is a container having some water. So at this point, this water bubble, or we can say a drop of water, will exert same pressure on each and every direction equally. We have to remember this as well. Now let us learn, or let us take an activity to practice how liquid exercise pressure with the help of this experiment. So take a container, fill it with up water, and then make 3 holes in it. Holes must be equal in size but at different heights. It can be noted that water coming from the top hole comes with low pressure and covers less distance from the see, this is a less distance, and water coming from the hole at the bottom here has maximum pressure and covers higher distance, larger distance comparatively to the first hole. You can see here. Now pressure exerted by air. Both liquids and gases exert pressure on wall of container as well. Blow a balloon and prick it with a needle. The balloon will burst as the air was putting pressure on the wall of container, and the container is the balloon, and when we prick it with a needle, the air comes out with a tiny hole and the balloon gets burst. Atmospheric pressure. We know that air has weight, and the force exerted by the weight of the air, that is known as atmospheric pressure. The instrument used to measure atmospheric pressure is called barometer. When a person sucks through the straw, the air pressure in the straw becomes low. The atmospheric pressure, which is higher, will force the water into the straw and then into the mouth. This is an example. We can think of one more example, that is vacuum cleaner applies the principle of atmospheric pressure to remove dust particles. Again, some practice questions. You can pause the video and check your answers after that on the next slide. Here are your answers. If your answers are all correct, then well done. You have made a really good progress by looking into this video. Keep it up like this. That's all for this video. For more videos, you could log on to justtutors.com. Thank you.